Hi, my name is Budiono, and I'm an electrical engineering student at Kettering University. And here we have our electrical engineering Capstone project. It's a kicker-catcher game. The object of the game is to kick the ball with the right knob, and on the left knob we're catching the ball to score. Here's a quick gameplay. We enter the quarter, into our point mechanism. The balls drop, and then we go on kick. And pop the ball, and the light flashes. As I keep scoring, the light flashes, and we increase my score, as you can see on the right side. And that's the gameplay of our kicker-catcher game. And now we're going to take a look at the back. Take out the power cord. Let's see. So we have a lock and key on the top. Just turn left to right and lift up and pull out. Inside you can see our solenoids that are using to pull the pins in, as well as speaker, power supply, and all the other electronics for the game. If you look closely, you can see that there's this slider mechanism that we use for the catcher. It uses a couple linkages in order to keep it easy for the user, as well as a linear ball bearing to keep it smooth at all times. Here's the solenoid for the ball feeding action. With this plunger, we feed the ball to the kicker. And this is the solenoid that we use to release the balls for the start of the game. Here's the power switch and our two speakers on the left and right sides. We are using an ammeter to keep track of the score. This solenoid is used to drop the balls at the beginning of the game, and the second solenoid on the bottom is used to feed the balls in every round. Notice the 8 solenoids and our relay board on top to control them. And here's how you pull out the coins too. During the design process, we used CAD software to visualize what the game would look like once it be put together. It allowed us to understand our physical constraints before we even started building. The building process was tedious and required lots of measurements. And on the electrical side, we had to solder on diodes in order to compensate for the back EMF from the solenoids. And the joints were protected with heat shrink, with the ends connected with professional connectors. The Arduino code was constantly being modified to ensure that the sensors were consistently picking up the ball during gameplay. Late in our design process, we learned that the ball feeding mechanism was not consistent enough for gameplay. This required a slight modification of the tolerances of the ball feeder. Another issue that we came across is that if 2 solenoids were triggered at the same time, there was a chance that the relay board would reset the Arduino. We crudely fixed this problem by only triggering 1 solenoid during gameplay. This means that when the ball is kicked, only 1 solenoid is retracted at a time, but every time the solenoid is retracted, it is different than the one previously.
Thanks so much for watching, guys. I hope you enjoyed our senior design project. A big thanks to Brian Ross and Joe Sabin for the help on tips and tricks in woodwork. If you enjoyed the game in this video, please leave a like and a comment down below.
But I'm not really scoring all that much.
It takes some time. It does. You got to really cash them in.
I'm still in poor. I haven't even
Yeah.
got par yet.
Yeah, it takes a while.
This is